Hi everyone, welcome back to day 2 of this coding camp. My name is Ira and I'm the Director of Business, and I hope you guys enjoyed today's camp.
Okay, so first up, we're gonna answer a couple of questions from yesterday. So I think the first one is we had a question about battery usage. So people wanted to know what's like the best way to like minimize your battery usage so that you don't like basically lose battery too quickly like during a match. So one way that like that's gonna drain your battery is if you're, let's say you have like an arm and you're holding your arm like up in the air with a motor. That's like a lot of work for the motor to do, so that will drain the battery really quickly. So a way to help with this is using something called counter springing. So what counter springing does is it's a force that works against gravity. So it makes it easier on your motors to have some arm like suspended in the air. It's a lot less work. So what this does is it basically balances the effort the motor uses to move the arm up or down. Like it basically works against gravity. It counteracts it. So that's like one way to minimize your battery usage. Yeah, and this also works with sliders too. So if you're trying to hold a slider at some position, it's much easier if you have some kind of counter springing. It's a lot easier on your motors. Yeah, is that good? All right, so now we are going to move on to the next slide. Yeah, so the second question from yesterday we wanted to answer was about forking a repo. So, yesterday what we did is we downloaded the FTC robot controller and then we created our own repository and basically moved that code into that repository. But another way to do this is to just fork the repo. So we'll demonstrate that really quick. So it's actually not very challenging at all. It's significantly easier than what we did yesterday. And it's in some ways it's better than what we did yesterday because instead of having to recreate your like repository every time or having to move all your code to like a newly created uh repo every time the FTC robot controller is updated. You can just pull in those changes into your forked repo. So it makes it a lot easier, like in the long term. Yeah, and that's called syncing. Yeah, so I'm gonna open up Chrome. So if we go to the FTC robot controller, yeah. So what you want to do this is basically click this drop down and you can click create a new fork and it's going to take you to this screen. So you can name this whatever you want. And that'll be the name of your forked repo. And then you can also choose your owner. Like so you can choose if you want other people to collaborate, you can use that.
Depending on the organization.
Yeah, yeah, depending on the organization structure, like you can select that here. And then you can add a description and then you create your fork and oh wait, hold on. Yeah, we'll just choose future Martians. So then you can create your fork. And then what it's gonna do is basically just create a new repo. And you can see it has all of the FTC robot controller code in it. And then now if you wanted to open this in Android Studio, what you'd have to do is copy this web URL and then open Android Studio. And you can do get from VCS and you just paste that link there and you can clone. Yeah, and then you can see it's creating that. Yeah. Okay. Are there any questions about this?
So the Only question I have is, does this make the repo public by default? Because it's a forked repo.
Yeah, because it is a forked repo, it does make it public. Yeah.
Okay.
And this is where the team has to really make the choice. Because if you want to have it private, it cannot be forked from the first repository. And I think this is probably why some teams go through the trouble of downloading, creating it, and then managing it that way. So in that approach, you would have to manually bring in any updates that were made, or you would create a new repo and just move the code over. The second approach would really not be ideal. But if, again, depending on where your team is and how comfortable you feel with having a public repo, if you did it this way, with the forking, you just have to occasionally keep syncing with the fork, and you'll be good to go.
Got it. Thank you.
So
There's no more questions, then we'll move on to the next slide.
all right. But I'll be talking about this. So just wanted to briefly touch on what exactly happens when you compile Java code. Now, a lot of you might already know this, or you might have some idea, but we want to cover this because when we talk about what Gradle does, we want you to understand how important a role Gradle is playing, because it is doing all this behind the scenes and makes it a lot easier. Now, let me ask, as we had indicated, the expectation was that you've all done some Java coding before. Has anyone here done Java using something like a text editor? Not an IDE, but a text editor. Has anyone done that? I'm gonna increase the number of thumbnails. Oh, participants, yeah, that's easy. Okay, I see one hand up. Yeah. So you know exactly how hard it is then, right? Because you have to firstly create a Java file. You have to name it a certain way, which is it has to match with the name of the class, and it has to start with a capital letter, and then you have .java. And then, so before I jump in, I just want to see if there were any other participants who raised hand. Okay. So for those of you who've used the IDE, to start learning how to code in Java, there's a lot that's happening behind the scenes, which may not be very apparent if you're just using the compile and run options, which most IDEs would provide you with. So when you write a Java source file, or when you put it together, that's the .java file. Now that code can be understood only based on having the Java SDK installed, which will take that Java source code and translate it into what is called the bytecode file, which is the .class file. So the .class file is what the operating system is then able to basically. So let's see, we have the compiler generating the bytecode, and then yes, you need the SDK to run the Java file which you have just compiled and created the class file. I'm going to rephrase or reword all of this, but is there anyone here who is not aware of that process, wherein you run compile first to create a class file, and then you run the Java command to run the class file? Is everyone aware of that process?
Yeah.
Okay. So what is important here to understand is the Java code itself is not simply going to be executed. That first has to be compiled into a class file. And then the class file is what is going to be executed, during which the operating system based instructions are generated based on what needs to happen, whether it's getting input through the keyboard or whether it's displaying something on the screen, or some other network activity that needs to happen. So as you can see, you already have to run 2 commands just to run a simple Java file. Now, when you have libraries, so let's say you are including some other Java file in this one, then you start getting into packages. Packages are the structure in which you're storing the source files. And when you have a structure like that, you need to make sure that there's a class path indicated. Otherwise, when you try to compile the code, it will not know where to go and find the files that you are trying to include or reference. And so this bytecode file can be executed on any platform, and it cannot simply be run on the OS. As you all know, Java is called a multi-operating system, or it doesn't depend on a specific operating system. What does depend on the operating system is when you install that SDK. So you will have to install an SDK specific for Windows or specific for Linux or Mac. But once you've done that, the act of generating and running the class file, those will be agnostic of which operating system they're running on. These are all very important factors involving Java. And execution of the bytecode requires an interpreter, which will convert the bytecode instructions to instructions for the OS to execute. So that's the one where you run Java and then the name of the class. So if you heard the term Java virtual machine, that is the interpreter. Now, in order to compile Java code, you need the SDK, Java SDK installed. But if you are simply looking to execute Java, then the JVM, which is Java Virtual Machine, is enough. You don't need the full SDK to execute the class files. And that's when it gets interpreted into machine level instructions for the operating system. Any questions regarding these pieces of the process? Okay. I'm sure most of you probably already knew all this, but just wanted to quickly refresh on those different. Okay. So Gradle is really a very important tool that we are utilizing in this. And it's not just for FTC, but even in the industry, there are these build tools which make it easier to work with a lot of code. So in this specific situation, as you all know, you have Java source code that needs to be compiled. And once you've compiled it, you need to package it, because you're not going to run it simply on your laptop. You are going to be running it on the control hub. And as we had mentioned yesterday, what you're really putting together is an APK. It is an Android app that you're putting together, and then that needs to be downloaded into the control hub. Now, the act of putting together this APK, and in other scenarios, not FTC, in a jar file or a tar file or a zip file. Now, all of that, again, needs a bunch of instructions to be used. That's for packaging. And then there may be other tasks like publishing the artifacts to some repository, or you may be referencing something that is in a different repository, not local to your machine. So you may need to pull that during build time and make it part of your APK or jar file, as the case may be. So the number of instructions that you need to do all this, as you're hearing here, are going to start adding up pretty quickly. You have compiling, you have packaging, you have pulling from repositories, then you have downloading into, which we call deploying, into the control hub. Now, if there's no build to automate this process, then you will need to perform all of these actions manually. So not only will you be running a whole bunch of instructions, if you make an error in even one of them, you'll have to then start debugging, going back and seeing what error happened. All this is made a lot easier by Gradle, which is a build tool used in FTC SDK, and it's also one of the cutting edge, or at least mainstream build tools in the industry today. So what that does is it makes it easy for you to run all these sets of instructions by, firstly, it gets tied into the Android Studio IDE. So all you have to do is basically select options. And secondly, behind the scenes, it's putting together the list. So depending on whether you're trying to deploy or whether you're just trying to build, accordingly, it will call only the set of instructions required or execute only the set of instructions required to achieve that much. Now, Gradle is a great thing to learn more about if you want, but we wanted to give you this much background so that you at least know what is this Gradle? Why do we have all those files there, and why do we sometimes make changes to Gradle, and what's the role it's playing in this whole process? But feel free to go and learn more about Gradle if you want. If you're into software, then definitely you want to know more about tools like this. There are so many other build tools. Maven is another option, but for this one, they're using Gradle. Any questions, anyone, about Gradle or about build tools in general? Okay, all right. So with that, I think we're going to move on. Who was going to talk about this one?
I think that was me.
Oh, okay, all right.
Yes, now we're going to talk about object-oriented programming. So object-oriented programming, or OOP, involves classes and objects along with their attributes and methods. And Java is a programming language that uses object-oriented programming. So for example, in real life, an apple is an object, and it's an instance of a fruit, which would be the class. The apple has attributes such as weight and color, and methods are what can be done by the fruit, such as grow and rot. And another example is if Jill, an object of class person, is eating the apple, then eat is a method that the class person has. A class is like an object constructor or a blueprint for creating objects. And you can look at the illustration to see the difference between the two.
Yeah, are there any questions about that? All right, in that case, we'll move on. So, all right, so now we're gonna get into actual coding. So the first thing I'm gonna do is just show you a couple basic things. So you're downloading code for the first time. So the way to do this is you need to connect a cable into the USB-C port. Oh, also, by the way, this is if you're not doing it wirelessly. So you have to connect a cable into the USB-C port on the control hub, and you have to connect the other USB end into your computer. And then you can click the build button at the top of the screen. And you don't have to do this every time. This is really just like the first time you should just build your code. And then once the build finishes, you can click the run button, and then that will download the code onto your control hub. So we can demonstrate that in just a second. We're just getting everything ready, but I can go into Android Studio and show you guys a little bit about how that works. So let's see. Gonna need this one. Okay, so once you connect the cable from your computer into the control hub, then over here, what's gonna pop up is this. And once you see that, then all you have to do is just click this run button, and it should be it'll start building and then downloading the code onto your control hub. So yeah, in just a second, we'll show you guys that process. All right, yeah, so you can see this is the control hub, and there's a cable plugged into the USB port over USB-C port over here. And then so now the other end is gonna plug into my laptop.
Now, there was a question yesterday about whether we have to use a cable or if this can be done wirelessly. So with Windows laptops, this can definitely be done wirelessly. With Mac laptops, we have tried but not been successful. We've like while trying, looking in on Google and looking through some threads, it seems like some people have succeeded, but we had not. And so anyone using Mac might be stuck using the cable, at least for now.
System wrong. Shoot. Oh, yes. Okay. Yeah, just saying, I realized I had the wrong project open. So yeah, now in just a second, we should see it pop up over here. Okay, the control hub is. So one quick thing, if your control hub is blinking blue, it means it's either like it's downloading code or turning on. So when it's blinking blue, it means that any device like connected to it, you won't really be able to like you're on your driver hub, for example, it'll temporarily disconnect when it's blinking blue, but then once it turns green again, it'll be back. Yeah, so you can see right now on the driver hub, it's disconnected. Yeah.
Are you all set up to download the code wirelessly, or is it? I'm asking if, in case you can show it to us on how you do it.
So we do have a Windows laptop here, so yeah, we can set that up in the background and then show that a little bit later. Yeah, but
Got it.
for the code demoing, it's gonna be done on the Mac laptop. But yeah, we can definitely demo that in a little bit though, once we get that set up.
All right, thank you.
Yeah, so now the control hub is green, which means it's, I don't know if you also see that. The light here is green. Let's see. Yeah, so that means it's turned on. So now we also have connection on our driver hub. All right, so now as you guys can see here, we can see the team code and then Rev Robotics control hub. So to download code, all you have to do is press this button and it will run the code. And yeah, you can see the build over here. Yeah, so the build was successful. So it's great. All right, and then the install was successful. So that means that we were able to deploy the code. All right, and so now our control hub is green again, which means that the code is downloaded and deployed. So, and then we can also see it on our driver hub. We can see we have connection. All right. So now I guess yeah. So now I guess we'll move on to the next slide, which is also pretty quick. Yeah, so navigating the SDK. So there's a lot of folders in the SDK, as you can see over here. So it's sometimes it can be confusing if you don't know where to actually write your code. So that's what we're gonna cover really quick. So if you just have the base folder structure, you can see 3 folders. So to write your own code, you're gonna want to go into team code, Java, this first one, like not the one that says generated. Go to Java, and then you'll see this org.firstinspires.ftc.team code. So open up that, and then this is where you'll write all of your custom code. So let's make that a little bit bigger. So yeah, this is where you'll write all of your custom code in this folder. And to create a new file, just right click on it, new, and then Java class, and then you can name it whatever you want, and then just press enter, and it'll create it. Yeah. All right, so the second thing is the FTC SDK comes with a lot of samples, a lot of sample code, and it's a really powerful resource, because you can see examples of a lot of things like moving motors, servos, and especially vision processing. So this is like a really good place to learn TensorFlow just by looking at the sample code.
I would like to add and say that almost everything that you need to really learn how to use the SDK, use all the hardware that you will typically use in FTC, there is code there for all of that. I would strongly suggest that the students go in there and look through as much of that code as they possibly can. Whenever they have a question, first go and check. You will almost certainly find the code there to do that. I think it's one of the most underappreciated sources of information because it's all simply out there. You can write pretty much all the code you need for your season just by looking through the sample code that is out there.
Yes.
One question on that. So if we want to try out the sample code, we'll have to copy it into team code and then try it. Is that right? Or is there a way to directly pick
There is actually a way to directly test it out. We'll show you that like a little bit later though. Yeah,
Okay.
but there is a way to do that. All right.
And just to get the curiosity out of the way, actually almost all the sample code has been disabled by using tag on top of the class name, and just removing that makes it available for execution through your driver hub.
Yeah.
Okay.
All right. So the sample code is located in FTC robot controller. Click on Java, and then here, and then yeah. So all these external samples, this is all of the sample code that we were just talking about. So you can see it has things like robot auto drive by encoder. So that could be pretty useful for autonomous to see how to like get your robot moving. And then it also has things like, yeah, April tag reading. That's also for vision processing. That's pretty important. So now if we open up one of these, you can see this is what it looks like. So yeah, this is the disabled tag we were talking about earlier. So if you just delete that and then download your code, you'll be able to see this file, like you'll be able to run this this Java file. Yeah. So I'm just gonna bring it back. Yeah, that's the way you would be able to test out the sample nodes.
Okay, so to run that, instead of choosing team code on the drop down up top, do we choose the FTC robot controller?
Okay, so this drop down up top is actually something different. The name team code is not necessarily related to the folder team code. It's just this is just the like run configuration. It's like in an IDE, whenever you want to build and deploy your code, you have to create a run configuration. So that's just the name of it. You can actually name this anything you want. Yeah, so that's not really related. Like when you run this, it'll deploy all of the code. So yeah.
Okay, got it.
Good question. All right. All right. So in that case, yeah, we can move on to the next slide. All right, so here we'll be just talking about like the structure of a program in FTC. So first of all, the FTC SDK offers two off mode classes. So it offers a linear off mode and just the base off mode. On this camp, we will be using linear off mode. It's the differences between these two. It's not huge. They are pretty similar. It's just about the structure. The structure is slightly different. So just we're just gonna use linear off mode. That's what our team. That's what my team has used in the past when I was in FTC. Yeah. So and also the place where you actually use that is when you're in the class, you just basically extend linear off mode. And if you wanted to use normal off mode, you would extend just off mode. So let's go to
So strongly suggest going through and understanding all the different annotations that are used, whether it's for teleop or auto, and then even disabling, all those are achieved through the annotations on the classes. So please do get familiar with those.
yeah. All right, so here we can open a program here. This is just a very simple program that runs a motor for 2 seconds and then stops it. So as you can see, first you have your package, you have your imports, and then here this at teleop, this is an annotation. So if you want your on the driver hub, there's two sections to choose a program from. There's the here, I can show you guys in the camera. So there's the right side, which is your teleop programs, and the left side, which is your autonomous programs. Yeah, where you guys can see that. Yeah. So for all of your teleop programs, you want a teleop annotation, and that will make sure that it's on that side. And if for your autonomous programs, you can just replace this with an at autonomous. Yeah, and then that would I think an at autonomous, and then that would put this program in the autonomous section. And the reason why this is important is because in your actual games, there's a way to basically link an autonomous program to another teleop program. So like even though you could technically put all of your programs as autonomous, even if they're teleop, you wouldn't want to do that because you wouldn't be able to link the programs, and that's really important to make sure that the switch from autonomous to teleop goes smoothly. Yeah. All right, so now we'll get into the rest of the code. So yeah, this is what we talked about earlier, your class, and we extend linear off mode. And then we can just ignore this stuff for now. So now the run off mode, this is where a lot of your like actual executive code is going to be, where you're actually like doing something. Yeah. No, I just clicked on something. Oh, there. All right, so yeah, so get back to it. Oh, so yeah, your runoff mode is where a lot of your executive code is going to be, and it's always going to follow this like same structure. So you need an override annotation right before it, and then public void runoff mode and throws interrupted exception. So that's going to be in pretty much all of your programs. Yeah. And so now the second line of code we want to focus on is the wait for start. So the way the run off mode is structured is there's an initialization stage and like the actual start stage. So everything before or above wait for start is all of your initialization. So you can see here we're setting up like our hardware mapping for our DC motor, which we'll talk more about that later. And we're adding some telemetry. Then what that means is on your driver hub, when you're running a program, you press init first, and then after you press init, it'll run the initialization stage and you see a play button. And when you press play, it'll actually run like the rest of it. Yeah. And then to stop the program, you would press stop. Or stop automatically. Yeah. So basically everything before wait for start is your initialization stage, and everything after is your actual like running stage, like your start stage when you press play. Yeah, with that, I think we can move on. Oh yeah, and also this is a pretty helpful link down here if you want to see the differences between linear op mode and the normal op mode. All right, so now we're going to be writing our first program.
Before that, let's ask some questions.
Oh yeah, actually, before this, are there any questions so far?
Yeah, please let us know if there's anything that's not clear or if you want anything repeated, because we want you to these steps, we really want you to follow fully, because every other program that we write for the rest of the day will follow a similar structure.
All right, if there's
Oh, yeah, sorry. I think yesterday, Hayden, you had indicated you have some hardware where you can test the code. Is there anyone else today that has hardware on which they want to be testing code, or do you just want to watch the code running here on our setup? Okay, so we'll assume then that you all want to watch the code running here on our setup.
all right, so actually, well, one thing you guys can do is you can write the files alongside me. So that's really helpful for like learning how to write code. I mean, the best way to learn how to code is by coding. So yeah, we can do that. So basically you guys can write the files like write the programs with me, and then we'll just test it on our end and show you how it works. Yeah. All right, so basically this first program is really simple, and it's what you guys saw like 30 seconds ago. It's basically just a program that runs a motor at 0.5 power for 2 seconds, and then it stops the motor. So if we go back to Android Studio, I'll create a new file. So that is going to be in team code Java, and then here. So new Java class, and we can call this it's like test motor, and then press enter to create it. Okay, and also, so when you have a GitHub repo set up, every time you create a new file, it'll ask you if you want to add that file to Git. So most of the time you're gonna want to add it, but maybe there might be some instances where you're testing something that you don't necessarily want to be pushed to the GitHub repository. So in those cases, you can press cancel, but we're just gonna click add.
And just want to clarify one thing. So when you click on add, what it's doing is it is getting it ready on your local repository side. And only when you commit it, it gets committed. So let me retrace that. So when you click add, it means you want this file to be made part of the repository locally at that point. And then when you hit commit, it is committing to your local version of the repository. And when you push is when it is actually making it out to the GitHub repository remotely. So if you have committed something but not pushed it, then please remember that the others won't have access to it till you have pushed that code. It's only the act of pushing that makes it go to the server and make it available to everyone else who will then be able to pull from GitHub. Any questions regarding that? Okay.
Right, yeah, so every time you create a new program, it's gonna look like this. So the first step that I always do is extending linear op mode.
And please remember, there's multiple ways to do this. When you create a new class, you can indicate the superclass right there. So it'll add the extends linear op mode when it generates that boilerplate code.
Yeah. All right. So when you do that, you're gonna get an error, and the reason why is because the way the linear op mode class is structured, you need to have run op mode also there. So what you can do is right click on it, click show context actions, and then you'll see implement methods. So just click that, and you'll see it wants to implement run op mode. So just click OK, and you'll have this. So now this is basically all, yeah, the boilerplate code that you need for every program you run. Yeah. So now we'll start on the actual customized code. So the first step is we need to create a DC motor object. So the place where you do that is before run off mode. So you create DC motor. And then you can see when when that showed up and I clicked tab on it, it also added an import. So most of the time it should add imports automatically when you type in like an object name, but sometimes it might not. So you might have to do that manually, but most of the time it will do it automatically. And we can call this object test motor. And yeah, so that's what we have here. And so then now the first step is to set up your hardware map with the motor. So, oh wait, actually really quick, anybody that's like following along and like coding this like simultaneously, do you have any questions so far, or are you guys doing okay?
So please let us know if the pace is fine, or if you want us to slow down or speed it up, or any changes to the way we're doing this. Okay.
All right. In that case, we'll continue. Yeah, so I was talking about the hardware map. Yeah, so the hardware map is essentially how the control or how the program knows like what port like each motor is on. Because let's say you have like two motors connected, the program isn't gonna know like which motor is which. So let's say you have like a slider and an arm, and then you write some code to move your slider. And if the program doesn't know which motor it is, it could just run your arm instead with the slider program. So that's why you have a hardware map. So half of the hardware map is going to be in your code, and the other half is going to be on the driver hub. So we'll show the driver hub part later when we test this program. Yeah, but for now, we'll show this part. So basically the way to do this is test motor equals, what is it? Yeah, hardware map dot DC motor dot get, and then you have the string. So whatever's in the string is going to be, then you have to have the same name like typed in on your driver hub. So yeah, that's what we'll show you guys later. So you can we'll call this test motor and have your semicolon. Okay. And then now, all right. So now this telemetry you see here, we'll talk a little bit more about telemetry later, but it's essentially a way to put messages or information on your driver hub, like when you're running a program. So we'll just add that real quick. Add data. So the first string is the caption. So you can this robot status, and then the second part of this could be it could be an integer, double, boolean, or it could be a string. It could be any variable type, but in this case we're just gonna make it a string. Say initialized. So the reason why it's valuable to have this is because when you press initialize, especially when you have like more complex pieces to your robot, like you have webcams and stuff like that, it actually takes quite a few seconds for the program to finish the initialization stage. So having some telemetry at the end of it is really useful because that way you can actually know if your robot's done initializing and if you're ready to run the program. Because if you run the program before it's done initializing, then some things just may not work because they're not fully set up. And also one more thing about this telemetry is adding the data doesn't automatically make it show up on the driver hub. You also have to update. So update will basically just update the driver hub with whatever data has been added so far. Yeah, that's what that is. And let's see yeah, and then the next step is wait for start because this is the end of the initialization stage. We need to wait for start, and then now we can actually run our motor. So this is the fun part. So you can call test motor and then set your power. And so we can just set it at like 0.5. That's a safe speed. And then let's say we want it to run for like 5 seconds and then turn off. And just have sleep for 5,000 milliseconds. And then you would set your power back to 0. Yeah. And also one quick thing, I wouldn't recommend like ever actually running your like motors in competition using like sleep. That this is just purely for demoing how to move a motor. Don't do this in competition. We'll show you like much better ways later on as we get more programs. Yeah, so now we have our program finished. Just make sure, yeah. So that means that we're ready to deploy our code. So we just click this button here to run the team code. And then now it's deploying. So let's see, yeah, build was successful. And then I think it's still running. Yeah, okay, the install was successful. So now, all right, so the control hub is still loading up. It's blinking blue right now, so it's still resetting from downloading the code. All right, so yeah, so now it's green and we have connection on our driver hub. Yeah. All right, so now I'll show you guys the second part of the hardware map, which is creating a configuration for your motors or servos or electronics on the driver hub. Yeah, so to create a configuration on the driver hub, click the 3 dots here. And then are you guys able to see the screen fine?
Yeah, yeah, it looks fine.
All right, and then click configure robot. And then so you'll get this screen. So I'm gonna show you guys how to create a new configuration. But once you create a new one, you can go back and like edit that one. So you don't have to create a new one every single time. Yeah, so you'll click new. Yeah, click new. And then you should see control hub portal. Click Oh yeah. Also, yeah, by the way, to create a configuration, you have to be connected to the control hub. Otherwise, you won't be able to do anything because the configurations are saved on the control hub, not the driver hub. So you have to be connected.
And this configuration, which is done on the driver hub, there is very detailed and excellent documentation available. Strongly suggest going through and understanding that, especially when you have an expansion hub connected also. We don't want to make this camp a lot about just that configuration. So we're covering some of the configuration here, but we strongly suggest going through that documentation, because when you're connecting sensors and other kinds of hardware to the expansion hub, there's again a different level of settings. Like you have to dig in to more depths to make those settings. So please do spend time. It's good to be aware of exactly how to do that.
All right, so next step is click on control hub, and then now, so now we're configuring a motor. So we want to go into the motor section. And so on our control hub, we plugged our motor into port 0.
So let
So
us
over
let
here.
us slow down the pace, kind of
Uh,
give pauses.
oh yeah.
So yeah.
Go through the coding and oh yeah, okay, yeah. We can step back really quick and go back to the code. Was there a specific part you wanted to look at? The complete one. Oh yeah, this program is it's a full program. Complete program. Yeah. Oh, and you know what? I realized that I forgot one step. So I forgot I have to add the at teleauth over here, that annotation. Otherwise, the program like won't actually show up in the driver hub. And did you have any like specific questions about this, or did you just need to finish writing it down? Yeah, just send a message once you're ready to move on, or you can give a thumbs up. Oh, and also if anyone has any questions, feel free to speak up. All right, got a thumbs up from Hayden. Oh yeah, so Hayden, you have the electronics available, correct? So are you
Yes.
yes, okay. So in that case, do you have a motor plugged into your control hub?
Uh, Give me a second. I can show you.
All right, yeah, that'd be great. Yeah.
I have that guy right there.
Okay, just your camera is a little bit blurry.
Sorry. Give me a sec.
Yeah.
Is that better?
Oh yeah, yeah, that's a lot better. Okay. Okay, not oh wow, you got a whole robot there. Okay.
Yeah.
So in that case, what you can do is you can like just like for this program to work, you could try and move just like one of the wheels. Like so
Yeah.
basically yeah, one of the drive motors.
Yeah. I've already got that done.
Okay, all right, that's great. Yeah.
Yep.
All right, nice. Okay. Okay, and Elias, is that correct? All right, you guys also have the electronics hooked up, Randy. Okay, that's good. Nice.
Yeah, we're able to do so.
Yeah. All right, in that case, I think now we're probably ready to move on. So I'm just gonna stop my share again really quick. Yeah, so I'll go back to the driver hub. Yeah, so for us, the motor that we have plugged in right now is plugged in on port 0, and it's go build a what is 5203 series motor. So we're gonna click on this, then yeah, there we go. Oh yeah, and then so I'm gonna click on this. So for you guys, you're gonna want to click on whatever motor, like whatever type of motor is you have. So it may not be the exact same as mine. And so for this program, we named our motor test motor with a capital T, capital M, no spaces. So we're gonna type in that exact same thing. Test.
Yeah, please remember case sensitivity is very important. It has to be exactly what you're using in the code.
Yeah.
It's
Yeah,
basically the
yes.
name of your hardware.
Yeah, so then click, once you have that done, you click done, done, and then save. And then now you enter a name for the configuration. So we'll just call this, I'm gonna call this coding. Yeah, coding. In 2024. That's okay, I'll show you. Yeah, so you just name your configuration whatever you want. And once you finish that, just click done and then okay. Yeah, and then now you have a configuration set up. So you can see we have the Coding Camp 2024. And anytime you want to activate a different configuration, you just click activate. And then when you click back, it'll restart the robot and activate that configuration. So that's, yeah, so you can see restarting robot. And then now you can see over here it says Coding Camp 2024, which means that's the active configuration. So does anyone have any questions about that? Is there any steps you guys want me to repeat? And if you did finish that step, then give me like a thumbs up or send something in the chat. Okay. All right, is everybody ready to move on to the demo, or you guys still working? All right, Hayden's ready. Okay. All right. Elias, did you guys get your configuration done?
Yes, we did it.
Okay. Also, really quick, am I saying your name right?
Thanks.
Thank you. Okay, so in that case, yeah, now we can move on to the demo. With this motor. Yeah, so this is the motor we have plugged in. So if you remember earlier, we set ours up as a teleop program. It's actually gonna be on the right side. And then it was called test motor. So select test motor. And now we're gonna initialize. So yeah, so robot status initialized. That's how we know that our initialization stage is done. So now we're ready to play. So I'm gonna show you the motor. Yeah, and play. Yeah, you can see it spins for 5 seconds and it should, yeah, and then it turns off. So that's all right, nice. It worked. That's good. Nice. Yeah, let us know in the chat if you guys were able to have success with the program or if you ran into any errors while testing. All right, you're done. Okay, nice. And Hayden, did yours work too? All right, nice. All right, great. In that case, we'll move on to our second program.
You want to quickly shift over and show how Windows laptops can connect directly with wirelessly.
Oh yeah, we can actually, yeah, that's a good idea. We can do that right now. So all right, what we'll probably, is that on the Zoom?
Yeah. No, it's not. And we
Oh,
won't be able to
okay,
have it
yeah,
on the
okay,
Zoom
we
because
don't,
it's connected. So someone can hold this. It's really simple, actually. Can I see? Okay, it's really simple. So you can see that right now we're connected to the Wi-Fi here at the fire station, and we only have access to the inbuilt devices, not the control hub. And now when we go in here and connect directly to the control hub, which is FTC dash. So when we connect to that, take this a moment.
Yes,
Okay.
it's
When that connection occurs, so it should show up here. It just did. Let me restart Android Studio.
oh wait, it might be because this is connected. Oh, it worked.
Oh yeah, okay. So yeah, there was an active connection from the other laptop through the USB cable, which is why it was not showing up. And as soon as that connection was disconnected, or that cable was disconnected, as you can see now, the control hub shows up. All it took was really just connecting through Wi-Fi to the control hub. I mean, you would imagine it should be as simple for Mac also, but the thing is with Mac, when it's not a Wi-Fi, actual Wi-Fi access point, when it's a peer-to-peer network, they have a lot of restrictions on the protocols and a lot of ports are closed down, which is why there's a need to set up something called an ADB bridge. And that's the configuration where we have attempted it a few times and just given up in the interest of time. But there definitely have been people who have succeeded in doing this with Mac. So if you have a Mac, please, the off season, now is probably the right time to try and have that working. You don't want to waste time during the season. But for Windows, it should be really simple. So is there anyone who wanted to try this in Windows? Please go ahead and try it now. Just connect directly to your control hub and see if Android Studio shows up the control hub as the device to deploy to. Okay, any questions regarding this? Okay, if not, we'll continue with the programming.
Yeah, I'm gonna share my screen. Okay, so yeah, we finished our first program. So now, all right, this our second program. So in our first one, we programmed a motor. So now we're gonna be programming servos. So it's really similar, and it's very, very similar. But the key thing with servos is unless you set it up as a continuous rotation servo instead of a normal servo, servos only have limited range of movement, so they can't keep spinning infinitely. That's why it says here you can see it says set position instead of set power, like it did for the motor. So I think
I want to add something.
yeah.
So this is a tough lesson that as a coach I learned and students, our team members learned in our first year of FTC, which is when you are using a servo, and most servos have this limited range of motion, like they may have 300 degrees of motion, which simply means you cannot have the servo rotating even one whole circle. So when you're mounting a servo, you really want to take care that whatever action you want your servo to do, that entire set of action is covered in that range. So to put it in other words, the starting point and stop point of that 300 degrees is not something that you can set up through software or change through some kind of app. You physically have to rotate your servo to make sure that the part that will be rotated by the program is entirely covering the range that you need to use in your robot. So for example, what happened for us was we had set up this little, let's see, I'm trying to look for a right name for that. So basically, it was in Cargo Connect where we wanted to have a servo move. Okay, yeah. So maybe I'll just illustrate it. So we had a little piece of metal like this, and the servo was going to move it over to make it fall into the delivery location. And so as you can see, this is the range of motion that's needed. Now the servo, which is causing that motion, if it so happens that the 60 degrees of motion, which is the dead zone, if that happens to be here, your code is never going to be able to do this. It's going to end up doing this or this. You'll never be able to get the actual range that you are trying to cover. So when you're mounting your servo, you will have to kind of run the servo, make sure you know where the movement zone is, and make sure that that movement zone overlaps with what you really want your robot to do. I hope this made sense, what we tried explaining. We just felt this is a very important thing to share. I know most of you are second year or multiple year teams, but for rookie members, this is a very important thing to understand because otherwise it can be a frustrating experience. Any questions regarding regarding the servo's range of motion?
So is there a way to increase the range, or that's not something possible?
So when we did this at that time, the only servos were still not capable of going a whole 360 degrees, at least the ones we had access to. But there is now a GoBuilder 5-turn servo, and that does go, it says 5-turn, but what we've seen is it's about 2.5 turns. So you will be able to use that one. But please keep in mind when you use that 5-turn servo, because of how there's now about 1,000 degrees of motion, when you use decimals, like 0.1 will move a lot more number of degrees than you would if you used a regular servo. So as long as you understand that and work with the right range, you may have to actually go down to the 3rd decimal point to get finer control of the servo. As long as you do that, that would be one way to avoid this issue.
Okay, thanks.
Sure. Okay, you guys can continue.
All right. Yeah, so after that servo overview, we can get into actually programming one of these. So, all right, let me switch to Android Studio. All right, so we're going to create a new program. So new Java class, and you can just name this test servo. And yeah, we can add that. And same steps as last time. Extend linear offload. Then add your run off mode. All right. So yeah, so now we've got all of the boilerplate code done. So we're at the, oh yeah, and then okay, then we also got to remember to do our @teleoff over here. Yeah. Okay. So now it's really similar to the motor. We have to first step create a servo object. Servo test servo. Yep. And then you can see that added the import, the servo import. And then now in our run off mode, we can set up our hardware map. Do test servo equals hardware map dot. Let me see what it is. Oh yeah, hardware map dot servo. Oh wait, it's okay. 1 second. Let me check this. Oh, it's in lowercase. Okay, so it's hardware map dot lowercase servo dot get, and then we have our device name. So we'll call this test servo capital T capital S, no spaces. Yep, and then I will add our telemetry. I'm just gonna copy paste that from earlier. Copy paste these three. Yeah. All right, so I know I was going a little bit fast there, but that's mainly just because this was pretty much a repetition of what we did earlier. So I'll just give you guys like a second to get to this stage. And also, if you have any questions or running into any issues, just let us know and we can help you out. Okay. All right, I'm gonna move on now. All right, so now the next step is the actual code. So the actual code to make the servo move. So what we're gonna do is we'll basically set the servo position to 1. So we mentioned earlier it has a 300-degree range, this particular servo. The way to basically control that range is choosing a value between 0 and 1. So that's how you control that range. So if you choose like 0.5, that's gonna go to 150 degrees. And if we choose 1, it will go to one end of the servo movement. And if we go to 0, it'll go to the other end. So that's what we're gonna try and do here. So basically, oh yeah, this is also, this can also be really helpful. Like let's say you're connecting a servo to like some mechanism and you need the servo to be like at a certain position before you connect it. You can just make a small program like this and basically move the servo to that position and then connect it. And that makes it really easy. So yeah, that's helpful for finding the like range of the motion. Yeah. Okay, so I'll go back here and add in that code. We do test servo dot set position. So first we'll set it to 1. Wait 2 seconds. 20 seconds. Okay. And then we'll set it to 0. Yeah. And I mean, and yeah, that's it. So let me plug the cable back into the controller. All right, so if you guys, when you guys get to this stage, just put a thumbs up or let me know in the chat. Oh, yeah, all right, great. Hayden's at this stage. So yeah, you can, once you're ready, you can just go on and download the code to your control hub. Yeah. All right. So all right, I think our code just downloaded. So in a second, I'll show you how to configure a servo on the driver hub. It's really similar to a motor. You just have to go to a different section. So that's what all right, so if you guys can see the driver hub, actually hold on, let me stop my share really quick so you guys can see the camera better. Yeah. Okay, so wait, focus. Yeah, there we go. So we can go to configure robot like last time. And then remember, we already created a configuration, so we don't need to create a new one. So we can click edit on Coding Camp 2024, and then go to Control Hub, control hub. So, all right, so then now instead of clicking on motors, we're gonna click on servos. So click on that. And so now our servo is plugged into port 0. So we're gonna scroll down. And so you can see a lot of different options here. But there's for right now the only option that we can use is just normal servo. So the brand of your servo doesn't really matter. Just click on servo. And you can enter the name. So we named ours test servo. Test servo. Yeah. Check that. And then from here you can go done, 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 and then save. Okay, and then if we go back, that's updating our configuration. But now one thing, if you guys will remember, the test motor from the previous program is still in our configuration. So there's two things you could do at this point. You could either delete that from the configuration on the driver hub, or in the code, that's what I'm gonna do. In the code, I'm just gonna add that motor, but not necessarily do anything with it, just to keep it consistent. So I'm gonna create, actually, I'm just gonna copy paste the code from earlier. We just create this here, and then just set up the hardware map.
So what happens if you don't do this? You write it down?
Yeah, so if you don't do this and basically you have that test motor in your driver hub configuration, but it's not in your code, when you try and run the program, it's going to give you an error and say like it could not find hardware device test motor. So that's the reason why we're doing this. So basically what I did is I just create the object and set it up in hardware map and then don't do anything with it after that. Just so that it doesn't give us any errors.
What happens in the other situation where you don't have it in your driver hub configuration, but you have it in your code?
Yeah, I mean, yeah. So if in that situation, when you have it in your code but not on your driver hub, it's the exact. It'll give you the exact same message. Could not find hardware device. Yeah. All right. So now if everybody's like gotten all these steps done, so the configuration and the program, if everyone has that done, just give like a thumbs up. Oh, and also, okay, so all right, Elias is done. All right. And then Hayden is done. All right, great. So in that case, we'll get to testing. Just a sec. All right, there's a chat. Yeah, so we can test this program now. Okay, can we comment motor code related lines alone and run it in the driver hub? By comment, do you mean like comment out? Are you talking about like commenting out the motor code? Okay, yeah, so if you removed it from the driver hub configuration, then yeah, you can comment out all your motor code and then run it. Yeah. So that we need to add the sleep at the end. I mean, all right, so, oh yeah, so one more thing about servos is because it's not setting a power, it's setting a position, the servo is going to move to that position and then stop. So, essentially it's not like setting a power of 1 and then waiting and then setting a power of 0. It's we're basically just telling the servo to go to this position, wait, and go to another position, so it'll stop automatically. Yeah. All right. Yes. In that case, we'll start on the demonstration. So get rid of the screen share. Okay, so we're
Typically, you would have something connected to the servo, like a servo horn. In this case, just for the purpose of demo, we have a zip tie or something like that.
zip tie.
Cable tie.
Oh, okay. Yes. Yeah, so we have a zip tie connected. Yeah, so we're gonna initialize. And now we see the message, so we know it's initialized, so now we'll run it. So, okay, interesting. It looks like we have some error.
Oh, there's a code in it.
Yeah, there's, so I'm just gonna quickly check the code really quick. Wait. Okay, I see a question. Remove the motor configuration from. Okay, so yeah, let me share my screen again. So what I was saying about removing the motor, so if you comment out all of the motor lines, then yeah, you can just remove it from the driver hub configuration, and then it's like the motor is just not there. But what we did here is we're setting up the motor with the hardware map, but we're not actually telling the motor to do anything. So it's not, the motor is not actually going to run now, because it's a different program that's only using the servo. It's not using the motor at all. Yeah, does that answer your question?
Because when you go to the list of teleop files that you can run, you'll be selecting the one that says test server, which means it will move the server, but not the motor.
Yeah. Okay. It's like no difference. So yeah, I'm just gonna check.
Maybe can you change the position to 1, or if it's already at 0.
It's interesting thing I read yesterday is yeah, so I'm just gonna check the configuration really quick and make sure.
Is this server?
There's a light. I'm sure it's
What the server you use?
yeah, it's exactly.
Shouldn't have been. So okay. Yeah, can you change the position to whatever is different from in the code? Like, can you change it to 1? I think in the code it says 0, right? Set for
This
0.
is 1 and 0. So that's 1 and then it goes.
Oh,
Yeah. So it should. Oh, okay, Elias, yeah, you have a question. Oh, okay, maybe it is in position 1 already. Yeah, that's definitely a possibility. But even if it is, then what would happen in that case is it would basically finish the like dot set position 1. It would finish that, then it would wait for 2 seconds, and then it would set the position to 0. So it would still move. But we could.
Actually, if you put a sleep at the end of the code,
Yeah.
it will put it in 0. Right now it's at 1.
Okay.
right.
All right. So is what you're saying, like basically just move this line to the end of the code?
No.
Copy it.
Oh, copy. Okay, yeah, we can try that.
This is zip time not.
No, yesterday when I was doing this server, it lights up somewhere. Definitely saw that. Yeah, I thought it was on the back of the server. Yeah,
Okay.
okay, yeah, all right, there we go. Okay, so we got it running.
Did it run it again?
Yeah, let's run it again. And
So that one went a good 270 degrees, didn't it?
Yeah, so this time, so I think what we just realized is, so I think, Elias was right. You do need the sleep like after a set position to 0. Otherwise, for whatever reason, the servo won't actually go to 0. So, and so I think what was happening earlier is it was already in 1, but then because we didn't have a sleep after the set position to 0, it wouldn't go to 0
Yeah.
either. So it just wouldn't move at all.
I would suspect that it was just the fact that it was re-executed, because when you give a command, it will follow that command before ending the program.
Yeah.
So I'm not so sure that sleep made the difference.
Yeah.
But yeah, I would definitely suggest this redeploy when you see some issue, definitely try redeploying first.
Can I say something? So we tried your code and it didn't move. After the first run, it didn't move. First run, it was moving. So then after the second run, we added sleep, and then it started working every time.
Okay.
Yeah. Mm.
Okay.
Yeah. Okay. All right. So, I guess if you guys all saw the demonstration, then like you can see, basically it went to 1, waited 2 seconds, and it went back to 0. So yeah, we can actually just run it again really quick. Show that. Oh yeah. So running. Yeah, it goes to 1, waits 2 seconds, and goes back to 0. All right, so now in that case, I think we can move on to the next program. It's okay, it's 11. Wait, what time's our break at?
So we'll take a break around 12 o'clock. But let's do one thing at this point. Why don't you quickly show what programs you intend to run? And then based on which one all the attendees are more interested in, let's focus on those. Again, we have, I think, some rookie members, but mostly veteran members. So let's make sure we get everyone's interests covered.
Yeah, okay, so the options we have next, next slide is about telemetry. So we'll actually just finish off this slide really quick. Yeah. So all right, so in a lot of those, like just now and like in the previous 2 programs, we've seen the use of telemetry just to know like when the initialization stage was complete. But this is only like one way that you can use telemetry in your programming. Telemetry is really useful because it provides a logging system, so you can constantly see the value of like variables throughout a program. So like when you have your full robot built, you have a lot of moving parts to it. So you have like a lot of motors and different servos. So you can log the positions and speeds of all those motors and servos with telemetry. So you can constantly see that, and that can help you debug at something. So like let's say your arm's not moving, and then you're able to see that like maybe the motor that's connected to the arm is not actually receiving any power, so you can know if that's some code issue or a hardware issue. And so yeah, that helps a lot with debugging and tuning and a lot of other things,
Including values that are coming from sensors.
yeah. And then you can also see values coming from sensors. That's also really helpful. And then we already talked about how to use telemetry in the program. Yeah. So all right, I think is there any questions about telemetry?
We definitely highly encourage using the telemetry for right from the beginning so that it becomes a habit. It's probably one of the most powerful debugging tools you will be able to use for FTC coding.
Yep. All right, so yeah, now we'll go through, well, I'll show you guys all the options we have. So we can show you how to code a motor with encoders. And then the next one is, we can also show you how to code a gamepad. What all components can be monitored using telemetry. So pretty much any like electronic device, like any kind of motor, servo, sensor, they all have like methods in the SDK. where that you can use in telemetry. So here, I'll go back to Android Studio really quick. So a servo, for example, you can have servo test servo dot get position. So that's a really useful one. Okay, that's so yeah, get position. So that's a really useful one. So the way you would use this is let me plug that. So yeah, so here in the second part of like a telemetry dot add data, you can put that there and
Copy that into the action code that once.
okay, yeah, we can do that. Yeah. Okay, yeah, we'll actually do a quick demonstration of that. So, all right, so we can, yeah, like after this, yeah, I'm just gonna, so yeah, we can call this like servo position, and then in here, you just add test servo dot get position. Right here, yeah, that here too. All right, and then I can call this like 1, and then this could be 2. Yeah, and then we also have to update the telemetry. So basically, we want to add data here and add data here, and then we'll update it over here. No, then it'll reset like now you can see both of them. All right, so yeah, now we added a little bit of telemetry, so we'll just quickly download that and then show you guys how you can see that on the driver mode when you run the program. Yeah. Yeah, so code's just downloading really quick. Should be done in a second. As you can see, it moves the servo, moves it back, and then now we can see the telemetry up there. Yeah. And then once the program ends, it goes away. Yeah, that's a quick like demonstration of how you can use telemetry to monitor your servos. Yeah. All right. Oh yeah, so I'm gonna go back to the PowerPoint. Okay, so we had, yeah, so the options I think were yeah, coding a motor with encoders, coding a gamepad, and then coding a distance, like yeah, we can use a distance sensor to trigger like motor movement, and then yeah, and then coding a drive base. So I think those are the 4 options. So
we can go through all of them.
yeah, we can, yeah, just like whichever one you guys want to go through like first, just let us know. I'll send them in the chat so that you guys can.
Do you also have something for like Pathfinder or TensorFlow and things like that?
So no, we don't have anything for like Pathfinder or anything like that. I mean, again, this is like a beginner coding camp, so that's a lot significantly more advanced.
So here's what we'll say. So in this camp, we really wanted to set you up so that you can use Android Studio and start writing code. And having done Roadrunner, which we used for autonomous, the amount of setup and configuration involved is significant. So we would suggest that if you intend to use Roadrunner in this season, please get started like right now, because the tuning itself can take multiple hours. And as we've seen, there's going to be repetition of steps, which can get frustrating. So you want to give yourself some extra time so that you're not feeling the pressure and trying to do it all in one day. But we have done Roadrunner. We have done it with our own PID algorithms also. So if there's any questions, we are happy to answer, and even happy to share our experience in using our own PID algorithm versus something like Roadrunner.
Okay, got it. Thanks.
Okay, all right, so we have 1 vote for encoder. And that's yeah, you guys can just keep just send a message in the chat. Like you can say like the number, like 1, 2, 3, 4, or just like the actual thing. Like,
So Ron, why don't you start going in order? And then when we break for lunch, we'll stop at some point, and after we come back, we'll pick up whatever's next.
okay. All right. In that case, yeah, we'll just for now, we still have a lot of time, so we'll just start with the encoder. Like, so coding a motor using the encoders. All right. So earlier when we ran our motor for using a sleep block, and then, or not block, we using a sleep, and then we stopped the motor afterwards. So that's not really a valid way to actually run your motors, like in a competition robot. It's not reliable at all. So that's why we can use coding a motor with encoders. So an encoder is essentially it's something that's in the motor, and it lets you keep track of how much the motor has spun. So that way you can use logic to spin a motor like a certain amount and then stop it. And it's a lot more precise than using using time. Yeah.
So would like to add something about the different modes in which these motors can be run. It is really important that the team members who are using code to run motors understand all these different modes that are available for running a motor in, and use the one that is appropriate for the intended application. So there's a run with encoders mode. You definitely want to be using that one when you are trying to move it along with indicating how much exactly it needs to rotate. And a few other, there's very detailed documentation available. If you're using GoBuilder motors, they have pages with information on that. But just want to call out a few things. There is one where you can run the GoBuilder motor with PID turned on. It's very important to understand that that PID is applying only to that single motor. So what it really means is when you want the motor to go to a particular position, it's going to accelerate, reach its top speed, and then decelerate as accurately as possible if you use the PID algorithm. And it does that depending on how many rotations were needed. If you were trying to move it through encoder positions which are mapped to just one rotation, it may not even reach full speed. It might just accelerate a little bit and then start decelerating immediately after. But if you are intending to use PID algorithm in its true sense, which is, I shouldn't say true sense, but in another manner, which is when you want 2 or more motors to be in sync in their behavior, then this PID mode provided by the motor is not what you're going to be using. You will have to implement and use your own PID algorithm. So please understand that distinction. Simply by enabling the PID mode on the motor, you cannot have 2 or more motors running in sync. That'll have to be an external effort to do that.
Yeah.
Any questions in that regard?
Can you explain that a little more?
Yeah. So let us say, and this robot which we have here, we can actually kind of show the robot. If you guys can kind of bring the camera here and show the sliders. So this here is a robot from a couple of years ago, and you can see that there's this slider on 2 sides. So there are 2 different sliders which are operated by 2 different motors. Yeah, that was right here. Okay, so these 2 different motors are running 2 different sliders. But then there's hardware which is connected to the end of that slider, which means there's a need for these 2 sliders to move in sync at all times. If one is moving and the other is not, it's basically going to put stress on all the parts that are moving together here. So to achieve that, what they did was they have an external PID algorithm. And what that does is it ensures that each of these is moving in sync together. So the code is keeping track of the encoder values of this motor as well as of this motor. If one of them is moving slightly faster, it gives corrective power inputs so that the other one becomes slightly faster and the one that was faster becomes slightly slower. And it does this in a continuous loop, and that's what PID algorithm does. I would definitely suggest getting familiar with PID algorithm. In fact, even FLL teams tend to use that to have more reliability in their movement of the robot. So what this ensures is these two sliders are always going to move together, and we won't have the risk of one of them having moved slightly faster than the other, causing mangling or some kind of distortion of the metal. Is that, was that helpful? Sorry, was this explanation helpful, or do you want me to explain that slightly differently?
Sorry, I was talking on mute. So yeah, that was extremely helpful. I do have one question though. So this PID algorithm, is it a library that works with motors, or that's a separate thing and we have to capture the motor statistics, pass it to the algorithm, and it will tell what to do with which motor?
So it's just a generic algorithm or mechanism which is used in the industry in various things. Like, for example, they even use it in furnaces to, let's say there's some metal that needs to be maintained in a certain temperature for it to be usable for whatever purpose. They use PID algorithm to make sure that it stays under a specific temperature and above a specific temperature. So if you look up feedback loop algorithms, PID algorithm is one of those you'll come across. And so PID stands for proportional, integral, and derivative. And what you'll see is the proportional part itself is many times enough. You don't really have to get into integral and differential. So it's kind of beyond the scope of this camp to get into the details of PID, but I would certainly encourage all FTC students to get familiar with this algorithm and try to use it whenever they can.
Okay, cool. Thanks.
All right, so now we'll get started on programming our motor with an encoder. So one important thing, if you're doing this, is you need to make sure you have an encoder cable going, so actually show on video. You need to make sure you have an encoder cable going from your motor into the control hub. So yeah. So if you guys can see this like blue, red, white, and black cable, it's going from our motor. It's plugged into the side over here, and it plugs in to the control hub right next to the power cable for the motor. Yeah, as you can see, it plugs in right there. So just make sure you have that plugged in. Otherwise, you won't actually be able to get the information from the motor that we need.
So basically, the motor has two different cables now. One is for power and the other is for data. And please make sure that both the power part and the cable for the data, which is the encoder cable, are connected to the same port, because every port number has two slots in there. One is for power, the other is for data.
Yep. All right, so gonna open up Android Studio.
Can you please repeat the last thing? So you mentioned that the power and the encoder cable are connected to the same port.
Yeah, so we'll just show this a little better. Can we have someone hold the numbers? So as you can see, what is being used here for this motor is port 0. So there's a slot for power, which was connected earlier also. and now the port for the data is connected as well. So if you can see here, this is port 1, and in port 1 you have one for power and the other is for data. So we're just indicating that be sure that you're using the exact same port for both the data and the power.
Okay, understood. Thank you.
Sure.
All right. Okay. All right, so now the setup is so if earlier when we were running our servo, if you had deleted that motor code or commented it out, it's now uncommented because now we're gonna need to use the motor. So what we're gonna do is create a new program, call this motor with encoder. Yeah, add that, and I'll just add all the boilerplate code. All right, so and then make it at Telyop. Yep. Okay. So now I'm just gonna copy paste the code from earlier, like in the servo program, and copy paste all of this stuff. Yeah, up to here. Yeah, here. Okay. And create your objects. Oh yeah, so again, in this program, I do have the servo still there, but we're not actually going to be using it. It's just there because I still have that servo in the configuration. I don't want to delete it. So I'm just leaving it in here. Yeah, but just reminder, we're not actually using the servo in this program. It's just being left there from earlier. Yeah. So now, all right, once you guys are at this stage, you have your motor configured and your initialization stage coded. Just give like a thumbs up or send something in the chat. Okay, yeah, so Hayden's got it. Let's see. All right, and then Elias got it. Okay. All right, so in that case, now we'll move on to the actual encoder bit. So the way we're going to be structuring this program is we're going to have a method outside of run off mode, and that's going to contain all of the logic for our what we're going to do right now. So if you guys are familiar with Java, you'll know what a method is, and you'll also probably know what parameters are. So we're going to start coding that method. So just void coder with coder. And then so we're gonna want to pass in an int called like target. Let's see, what did I call it here? Yeah, we'll call it target encoder pose. So what all this is, it's just gonna be what encoder position we want the motor to like move to. So like let's say like 1000, for example. You could pass in 1000 when you use the method. And so we can actually we'll set it up over here. So encoder with encoder, and want to move it for 1000 encoder ticks. So one more thing, the way encoders are, like the measurement you call it an encoder tick. Yeah. Okay. So now the next step is we need a while loop because we're going to be essentially turning on the motor until we reach some target position. Basically while. So yeah, all right. Here, if you guys remember earlier when we were doing that servo program, we had like a servo.get position. This is really similar with the motor. It's you do motor.get current position, and what that does is that returns the current reading of the encoder for the motor. So that's what we're gonna do. Test motor dot get current position. So while test motor dot get current position is less than encoder pose, or it's target encoder pose actually. Yeah. So we want to create that while loop with this condition. And so basically what this means is so once this condition is met, that means like once the motor is at the encoder target position or higher than it, it's going to stop the loop. So that's exactly what we want. And then in here, we just want to set our motor power. So we can set it to 0.5 safe speed. And then once we exit the loop, we obviously want to turn off our motor. So test motor dot set power 0. Yeah, this is all complete. Are there any questions about this so far? Oh, and also, one thing we can do is we can also add this current position into our telemetry. So yeah, we'll actually do that. That would be pretty cool. Gonna have a telemetry dot add data current. Yeah, and then just copy that dot. Yeah. Actually, no, we'll add that underneath. Looks a bit better. Yeah. Okay. All right. Are there any questions so far? Why do we have to? Actually, you have a good point. Actually, it's probably a better practice to keep this outside of. So what we'll do is, yeah, set the power right before the while loop, and then that way you only set it once. So, yeah, no, you're right about that. Yeah, we set our power, then we enter the loop. So we're basically just updating the telemetry until the condition's met, and then we set the power to 0.
So what is the initial position of the motor? So when it starts, the get current position is that at 0 and it's trying to get to 1000?
Okay, so when you turn on the control hub, it's gonna reset all of the motor. Yeah, it's gonna reset all of the encoders to 0. So yeah, that's what I was gonna get into that into a second. If we want to make sure this works every time, yeah, we do have to reset the encoder position in the code. So yeah,
Yeah, whenever you're using the encoder, please
Yeah.
do call reset encoder position
Yeah.
so that it sets it to 0. And then
Okay.
depending on the logic, you may be resetting
Where's
it
the-
later on, but based on logic, you'll be picking when you want to reset it.
Okay.
All right, yeah, so this is the way for to reset the encoder. It's it's a little bit long, but yeah, you have to do test motor dot set mode, and then you have to have your DC motor dot run mode dot stop and reset encoder. Yeah. And also a good practice is to also have this like in your initialization. Yeah, that's so we'll add it here. All right, so if once everybody's at this stage, just give like a thumbs up or send something in chat. Yeah, all right, we got Aiden.
I'll just ask a question while everybody's is writing the code. I'm trying to imagine how the real world application for this would be. So we're getting this feedback on the encoder position. So
Yep.
how much the motor has rotated. So with that feedback, we can stop the motor or continue to go. Is that like can you give an example of what?
Yeah, I can give an example of that. Yeah, so if you guys remember earlier when we showed our robot, we had two sliders. So if you wanted to, this is really useful for controlling sliders. It's like, let's say in your teleop, you want to press a button and then have your slider go to a certain position. That's you would use this kind of program in that situation. And also one quick thing about this is like the most basic, like simplest way you can write this. You can get like a lot more complicated. This is just for right now, we're just showing a really simple program. But yeah, let's say we want to press a button and have our slider go to a certain position. So let's say that position was like the motor has to turn like 1000 encoder ticks to get to that position. That's good. That's a good this is a place where you could use this program right here. So you press the button and then you would call this method and then feed in like 1000, and then that would accomplish what you want. You press the button and the slider goes to some position.
Okay, cool, thanks.
Did that answer your question?
Yeah, I did. Thank you.
All right.
Since it's 12 o'clock, let's take a quick break.
Okay.
So just like yesterday, we'll take a 20-minute break. So talk to you all about 12:20 Pacific time. Is that good?
Yeah. Okay. All right.
Yeah, you can just stay on.
We'll see you in 20 minutes. Okay, hello everybody. Break time is over. It's 12:22. So you guys could all just like come back to your screens and just give me like a thumbs up if you're back. Yeah. All right. Nice.
Can I ask a quick question?
Oh yeah, of course. Yeah.
Can you show me that that cable that goes between the control hub and the motor for the encoder?
Between the control hub and I can show you that cable.
Visible?
Okay. So that one, is that from Rev or from GoBuilder?
It's from Red. It should be from Red.
Okay. Okay, I'm not able to find it in my kit, so that's what I was wondering. All right, thank you.
When you buy most products, they should just come with it. Like there's a
Most
package distance
motors
sensor,
should come with.
and then there's just that same wire inside it.
Yeah. Okay, I'll look. Thank you.
The camera.
Is Go Build? Okay, so there's a question from Stefan. Is Go Builda better than Rev? So, I'd say for purely just for parts and motors, I would say Go Builda is superior. Like they're the for building so all of our previous FTC robots have been built with Go Builda, and we really like it. Just the platform is like it's really easy to build a lot of like complex mechanisms and put it all together. And also the motors are really good motors. They're say they're probably like some of the best motors you can get in FTC. Yeah.
One more question.
Yeah.
So when we install all of these in the robot, how is there a way to tighten these wires so that they don't come loose, or they are pretty stable and we don't have to worry about it?
So you can actually, so the way we did it is we use a lot of zip ties.
Okay.
Then you can just zip tie them all together and then cut off the end. And then it really helps keep the wires clean. But other than that, not really.
Okay. And did you all use the GoBuilda battery, or did you use that flat slim battery from Rev?
So right now we've been using the Go Builda batteries. Yeah.
Okay, but when you were competing, like I'm just
Yeah,
trying
when we're
to
competing, yes, we're using the Go Builda batteries.
GoBuilda batteries. Okay.
And then also for the wiring, one more thing is that if you have like slides or something that are extending up and you need to wire something that's on the top of those slides, something like an e-chain or something like
I'm sorry, can you please repeat that? I'm not able to hear. The volume is low.
I'll come closer, yeah. So what I was saying is that if you have like some extending mechanism like okay, if you have some extending mechanism like linear slides or something similar, then use something like an e-chain, which is like it extends based on how high your slides are going, and that helps keep your wires clean if you need to wire something that's at the top of those slides.
Okay. So what is that called? E-chain?
Chain, yes.
Okay. Yes.
All right, so if everybody is back, I think we'll resume with the programming. Yeah, just keep it pointed here.
Okay.
Yeah, so let's see, where were we? All right. That. So yeah, so if you had all of these steps done, just give me a thumbs up. Okay, Aiden's got it. I think there might be one step I'm missing. It's using encoder. Yeah, okay, so there's one more thing you have to do. So in your initialization, actually we have to put that before so in your initialization, you need to make sure that you have this line of code. Yes, it's really similar to the stop and reset, except it's run using encoder. So we during the break we were testing and we ran into some small issue. So right now we're just trying to resolve that really quickly so that we can show you guys like the right thing. So yeah, be just a second. Yeah, so all right, if any of you guys actually want to test this code and see if it works, yeah, you guys can go ahead and do that and like let us know your results.
Can you scroll up a little bit?
Oh yeah, down. Oh yeah, sorry about that.
The other way, I'm sorry.
Oh, other way. Oh, okay.
Okay, so in here you've declared the motors and the servo as instance variables in the class.
Yes.
So does all of the motor servos, sensors, do everything go in there? Or it's just that or is there a reason why they are in there versus inside the method?
Yes, there is a reason. So you if they were inside of this run op mode method, then that means they wouldn't be global variables, so they'd be constrained to this method. So let's say it's like we wouldn't be able to use them in here, for example. That's the reason
That's
why.
the only reason. Okay. And how often does that that run op mode block runs? Like once it starts, it's got the wait for start, and then so this is everything before wait for start runs once until the start button is clicked, is it?
Yes, correct.
That's the initialization code. And
Yeah.
then the move motor with encoder, is that running just once or how often does that run?
Yes, so this move motor with encoder, yes, it is running just once and then it kills the program.
I see. So it's not like that other class where certain methods keep running over and over. I forgot what it's called. It's not the linear op mode. It's the alternative to that.
Yeah, yes. Wait, so sorry, could you repeat that last part really quickly?
So instead of using linear op mode, there is one other option
Yes.
where certain methods keep running over and over, right?
Oh, so the thing with the other op mode is there's the way it is, I can't remember the exact structure, but I'm pretty sure you have a method called init. You have you have one more method in for that's in the equivalent of run off mode, which only runs once. And you have another method, I think, called loop. I'm not entirely sure what the name is. But so the way you recreate all of that with linear op mode is so like in your teleop program, for example, when you're driving your robot around, you have a huge while loop. So while op mode is active. So you have a huge while loop, and then that way you have a loop running, so you can put all of your gamepad logic in here. So that was probably what we're gonna get to next, the coding a gamepad. Yeah, but for right now though, because we're only doing this, we don't have this while off mode is active yet because it's not necessary for our current program. But yeah, when we start going into programming with a gamepad, then we'll have this, and that I think does that answer your question?
Yeah, it does. Thank you.
Yeah. Okay. All right. Just a second. We're just gonna make sure this works, and then we'll be back with you guys. Right. Okay. Yeah, that's all right. Okay, so a couple of just like really quick changes. Oh yeah, so one thing in this while loop over here, we had this condition. So one thing when you're programming in FTC, anytime you have a while loop, you always want to have the off mode is active as part of that condition. Otherwise, what happens is even when you stop your program, this while loop, the life cycle of it doesn't actually end. So you could stop the program, but your robot could just keep running, which is really dangerous. And also it will throw a lot of errors. Like let's say if you stop your program and you try and run it a second time, the second time you run it, there's going to be errors. It's not going to work how you're supposed to. So anytime you have a while loop, you want to make sure you have a off mode is active as part of the condition. Yeah, so add that in. And then in addition, we also have, yeah, this one more, it's run using encoder. And so I think earlier we had it placed over here. You want to actually just move that in the method and after stop and reset encoder. Yeah. Yeah, once you guys all have that, you can none of the configuration should have to change, like in the driver hub, because we don't have any new electronics. Yeah, so you can go ahead and test it out. Yeah, and if you have any questions, you guys can ask. So, all right, if you guys are you guys like all do you guys have all this code done? Or are you in the middle of testing? All right, yeah, Hayden's got it done. All right. All right, Elias's got it done. All right, yeah. So you guys, once you test it, just yeah, you can let us know how it went. Just you can send a chat message or unmute and just tell us about it. Okay. Good. All right, nice. That's great. All right. Nice. So I think the next thing we're probably gonna do is programming with a gamepad. That's a really like useful thing. And also it's kind of a good segue into programming a drive base. So I think that's probably what we'll do next. Yeah. All right. If you guys are ready to move on, just give a thumbs up. Yeah. All right, Stefan's ready. All right. Okay, looks like we're all ready to move on. So let me go to that gamepad program. Second. All right, so yeah. Okay, so yeah, so as I mentioned earlier, in a linear off mode, the way you have a loop is with a while off mode is active, in your run off mode method. So this is an example of that. So it's very simple logic, but essentially in your while loop, you can set your motor power like to say, for example, your gamepad right stick Y. So that means that the right joystick on the gamepad, the up and down, that's the Y. So whatever value that is, that'll be set to your motor power. So this is a decent way to, or this is a really, like this is kind of how you would control a drive base, like a really simple version of that by setting your motor powers to what your joystick value is. Yeah. So what I'll do is we'll code this from scratch. So get new Java class, call it gamepad S. All right, add that stem. Okay, so you need all the same objects as before. You need your test motor, or you need your servo and motor. All right, and then let's get the hardware map. Yeah, the initialization. All right. Okay. So now we need to add our while loop. So while off mode is active. And then, all right, so one quick thing about gamepads is so you can have two controllers connected at once. So the way you call the controller object to like get a reading from it is really easy. It's you can call it like directly from the SDK or from linear off mode. So you do this dot gamepad 1 or gamepad 2. So gamepad 1 is would be user 1 on your driver hub. So yeah, so when you're on your driver hub, you can see like if your gamepad is connected to user 1 or user 2, or if you have two gamepads connected. So gamepad 1 would be whichever gamepad is on user 1. And we'll also show that in just a second. Do this dot gamepad 1, and then if you do another dot, you can see all of the different readings you can get from it. So there's a lot of them. So for this specific thing, we want the right stick Y, I think it was. Where is that? Start time. Yeah, right stick Y. And then, okay, let me put it in a set motor. So yeah, we wanted to set our motor power to this value. Yeah. And one quick thing to note about a gamepad is, so if you look at my camera really quick, so if you move the joystick up like that, if you move it all the way up, the reading you're gonna get from that is -1. And if you move it down, the reading you're gonna get is +1 in the Y direction. So that's something to note. It's kind of counterintuitive because you'd imagine up would be +1 and down would be -1, but it is the opposite. So let's say if you want up to make your motor spin in a positive direction, you can just add a negative sign here. Yeah. And that'll just basically negate it. And also one more thing, let's say you wanted your max speed to be something lower than 1, which is like 100%. If you wanted to do that, you can add a multiplier. So you could make it like, let's say you want 0.5 to be the max speed, you could do 0.5 times that, and that'll basically just lower your speed. Yeah.
I just want to take a moment to share an experience we've had before while using these gamepads. Now, if you don't take care of these gamepads, like if by mistake they fall off or something happens during travel and things like that, what we have seen happen sometimes is when the joystick is not being moved, instead of being at 0, it will actually have a small value, like 0.05 or 0.1 or something like that. So please make sure that you take care of the gamepads. And once you see that there is a seep like that, like in the neutral position, if it's giving out a value, you probably want to swap out that gamepad. So just something to be aware of if it's behaving in a manner that you can't explain, where without the joystick being moved, if you're seeing that the mode is moving a little bit, it's probably something like that.
Yeah. Okay, so now we're just gonna add the second part of this, which is moving a servo with buttons. So you say if one, let's say if you press A. So one thing is for the condition, you can just do this because gamepad 1.a will return true if A is pressed, and it will return false if it's not pressed. So this is a valid way of doing that. And then so inside, then you could set your servo position to 1. So if you press A, it'll set to 1. And then if you press, you can make it set if you press, it sets it to 0. Yeah. All right, so now once everybody's here, just give a thumbs up. And on our end, we're gonna test and show demo. All right, so we got Hayden. All right, yeah. All right, so we're just deploying our code right now, and then oh yeah, we'll also show you how to connect the gamepad and how to like choose if you want it to be user 1 or user 2, because there is a way to do that. All right. So yeah, if you guys look at the camera really quickly, I'll stop sharing momentarily. So yeah, if you guys look at the camera really quick, so you can see the gamepad is connected by the cable, but over here, you can see user 1 and user 2, but both of them are blank. So in order to put this gamepad as user 1, you want to press the start button and press A, and then you can see it popped up on user 1. And if you want it to be user 2, you press start and B. So you can switch them like that. You can go A, B, A, B. So right now we want ours on user 1. So we're gonna set to that. And then now in just a second, we're gonna run the program and show you the demonstration. All right, so let's go to. All right. So first, we'll start with the motor. So you can see we have the motor here. If I move the motor up, you can see it spinning and has a max speed of 0.5. If I move it down, it spins the other way. So yeah. And then now for the servo, if I press A, it goes to 1. If I press B, it goes to 0. So A is 1, B is 0. So yeah, this is like a really basic demonstration of how you would program a teleoff. Were you guys all able to get, I'll share my screen again. Were you guys all able to get the code done? And if you were and you tested it, all right, nice. And Hayden, were you able to test that? And how did it go? You can send something in the chat or you can unmute. Yes, okay. Nice. All right. Your driver station died? Yeah, okay, that's unfortunate. One thing, so one quick thing about these driver stations is they have this issue where the battery in the back is it's not really perfectly like fit in there. So sometimes if you shake it, it can just turn off randomly and then it won't turn back on. Sometimes the best way to fix that is, it's kind of weird, but you kind of have to like hit it sometimes and that'll get the battery back into place, or you might have to shake it around. Yeah, but that does happen occasionally. So yeah, you can see when I hit it, and I actually moved the battery out. So now I have to
Or did
turn it
that
back on. Yeah. So now let's see if I can turn it back on. Yeah,
Not the right time to turn it off.
yeah, I guess it,
But one more thing teams have done is they take a little piece of paper, fold it up to thicken it, and then lodge it in between the battery and in the corner that is away from where the metal contacts are. So that way you're forcing the battery more towards the metal contacts. We might have to use our backup driver.
yeah. So, I guess, I think everybody's ready to move on now. So in that case, what we can do is we can move on to coding an actual drive base. So let me, and this is kind of similar to this piece of code over here, just a lot more complicated and there's a lot more to it. So let me see if I can open that. Yeah. Okay. So one thing is there's a lot of different drive bases like in FTC. So we've used a tank drive base before and a mecanum drive. So mecanum drives, you can obviously strafe around, which is really useful in autonomous and teleop. So we're going to be demoing that today.
Actually, a quick question. Ron, if you want to switch to the slides and show what we have.
Oh yeah.
We want to make sure that we cover what you care about the most.
Oh, yeah.
Because the code for mecanum drive, we can definitely demo that if that's the one that you all want to see. But it is kind of, similar. You're just working with 4 motors together instead of just one.
Oh yeah. So it's kind of weird, but you have to momentarily like disconnect it just so that you can start turning it on. So I'd say disconnect it, hold the power button, and then once you see like the rev icon, then just plug it back in and it'll turn on. Yeah, it's really weird. They don't really allow you to turn on like when it's charging. It just shows you that charging icon. Yeah.
If you press and hold, does it not turn on while charging?
No, I just keep showing you the power.
Anyway, quickly, so I know there was one request for distance sensor, so that could be one thing we do. Or you want to quickly show what other?
Oh yeah. So yeah, the options were, okay, so yeah, distance sensor, drive base, and
Can you go down to some of the other slides? Given that we have about 10 minutes, I want to make sure we cover what everyone cares about the most. Can you go to those slides? Yeah.
these ones, yeah.
So the machine learning slide, we, based on our experience, we have just summarized it in a manner that would make it easier for younger students to understand. So hopefully this helps the students understand, and if mentors are here, helps you with some wording that the kids will understand easily. And then, wait. So that's one we had, and then, so TensorFlow, let's see, I think we have links here which would help. Yeah, so there are a bunch of links here which will help you with respect to TensorFlow. Some of these links, so before we share this, we will update everything to make sure that it those links are specific to the latest season that has just finished up. So given this, if there's any specific topic, we can do the distance sensor mover motor, because this one is just going to be a repetition of a lot of the motor movements. But there's logic to it, and you can all see that logic here. We'll be happy to share these programs, but like I said, all these samples are available in the samples subfolder. So since we have time for maybe just one more program, does everyone want it to be maybe the distance sensor to control a motor? Okay, I see a thumbs up, so maybe let's go ahead and do that. Okay.
Okay. All right, so yeah, in that case, we will show the distance sensor. All right. So, yeah. Okay. So, all right, I'm just really quickly gonna delete a couple of useless things from here just to cut down on the amount of stuff. Yeah, okay. Okay, so let's make a new program and we just call this distance sensor like move motor, maybe. Yeah, distance sensor move motor. Okay, and then add all the boilerplate code. All right, and then so then we're gonna want to add. So we're gonna want to have our two objects from earlier, the motor and servo. Oh wait, that's wrong. Yeah. Along with a third one, which is a distance sensor. So for that, you're gonna want to call the distance sensor class, and then you can just name it whatever you want. I just named it test distance sensor. All right, and then for your hardware map, motor and servo are the same as earlier. But now the distance sensor, however, is slightly different. You have to use a slightly different method than we used earlier. So instead of going like hardware map dot DC motor dot get, now just use hardware map dot get, and then in your parentheses, you want to have two parameters for that. You want to have distance sensor dot class, comma, and then just whatever name you have for it. And the reason for this is because for actually it might have been, wait, I'm gonna let me check something really quickly. Yeah, so for whatever reason, the distance sensor class is not available like you do hardware map dot. And this optical distance sensor is it's something different. It's not the class that we're using right now. But yeah, but for whatever reason, it's not available. So that's why you have to do this kind of slightly different method. Yeah, but it's very similar. It's just a slightly different syntax. Yeah, because yeah, the hardware map class is basically doesn't have doesn't support like the distance sensor for this method. Yeah. All right, let's add the rest of that. All right, so once you guys have all of that, we can get into our actual logic. So logic is not too complicated. It's really just this while. So it's similar to just when we program the gamepad, we need a while off mode is active.
Right, can you please go back to that hardware map part? Just want to clarify exactly what the difference is for the hardware map. Now with the motor and the servo, those are specific methods that are available for that class type already. Whereas for the distance sensor, it's not, it's a very specific class. That's why you use the generic get method and then provide the class type that you're assigning to that particular object. So the I2C, this is under the I2C ports, right? Those, the distance sensors, right? So for each of those, you will need to provide the specific class that you are going to assign or use as a blueprint to create the objects. If there's any question regarding that, please go ahead and ask us.
All right, so yeah, I'll give you once you guys have all of this code. Oh yeah, actually let me just break this code down really quick. So in our while loop, we have a if condition. So this is the method that you would use to get the reading from the distance sensor. So essentially it's pretty simple, whatever distance it's currently reading, like from whatever's in front of it. And you can also change your unit. So you could get it in inches or millimeters or meters. For this demonstration, we're just doing in centimeters. And so what this is going to do is if our reading is less than 10 centimeters, which means if whatever is in front of the distance sensor is closer than 10 centimeters, we'll set the motor power to 0.5. Otherwise, we'll set the motor power to 0. So what that's going to do is if we're within 10 centimeters or something, the motor will turn on. Otherwise, it will not. And so this is pretty useful. You could use this in autonomous. Let's say you have to pick up a game element. You could say when you get to the certain distance away from that game element, then you run your sequence to pick it up. So yeah, it's a pretty useful use case of the distance sensor. Yeah. So yeah, if you guys all have this code written down, just give a thumbs up or something in chat, or you can unmute too. All right, Hayden's got it.
I'm not sure if I have an older version, but I don't see a get distance method in the test distance sensor. I only have
Is the distance sensor class you're using, is it this exact one?
I think I know them. I know the problem.
Oh, okay.
I named my class as distance sensor instead of distance sensor move motor.
Oh. Wait, were you able to resolve that issue?
Yeah.
Okay.
Yeah, I just had the class name the same as distance sensor, so it was not. It was trying to search for the methods inside.
Okay, that makes sense. Yeah, okay. Yeah, that's if your class name is this, yeah, okay, that's makes sense now. All right, in that case, I just will show you how to configure the distance sensor on the driver hub because it is slightly different than the motors and servos. Yeah, so the distance sensor. Oh, actually, wait, let me stop my screen share really quick so you can see this better. Yeah, so the distance sensor is an I2C sensor. So on our control hub, yeah, so on our control hub, you can see there's there's the I2C port. So we have ours plugged in to one on the I2, like port 1 on the I2C port. Yeah. Yeah, so yeah, and one thing, port 0 is the IMU sensor, which is built into the control panel. Yeah, so the way you would configure it is go to I2C bus 1, and then you would click add, and then select the, I think it's Rev 2-meter distance sensor. Yeah, Rev 2-meter distance sensor, and then you would enter your name. So I think we named it yeah, test distance sensor, capitals for yeah, s- are you guys all able to see that? Yeah, test distance sensor, yeah. All right, nice. So yeah, then you just click done. Click done, and then save it. Yeah. And then you can go back. Yeah. And it'll update that configuration. Yeah. And then now, yeah, I think I don't believe I've actually deployed the code, so let me do that. Were you guys all able to get that about the configuration, or do you have any questions? Oh, and then oh, okay, I see. Elias had oh, yeah, I think that was answered. Yeah. Oh yeah, and if you guys didn't get all the code, I just opened it up again. Yeah, so in just a second, yeah, now we're gonna do the demonstration of this program. Oh, they have forgotten one step. Oh yeah, okay, I forgot to add the @tell y'all. Yeah, let me redeploy that. All right, so now we're gonna run this program. It's distance sensor initialize. All right, so yeah, there you go. All right, nice, worked pretty well. So you can see the distance between here and my hand is greater than 10 centimeters. But now if I move it closer, it's less than 10 centimeters, so the motor moves. So yeah, this is really useful because let's say you're coming up to a game element, you get a certain distance away from it, you can activate your pickup sequence. Or if you're scoring a game element, when you get close to like the scoring location, you can drop it. Yeah.
So one question we have often gotten asked is when to use a color sensor versus when to use a distance sensor. So the distance sensor works really well when it is up to 2 meters or less. And anything beyond that, I wouldn't use a color sensor either. But as you get really close, there may be scenarios where you may benefit from using the color sensor for more reliability, especially if you're looking for a specific color. But the distance sensor is really a very good sensor, and we have tended to use the distance sensor more than any other sensors, of course, apart from the gyro and the webcam for TensorFlow. So if you have any questions about that, we'd be happy to answer that. Okay, I know we're a few minutes over the end of camp time, but I hope this was really helpful. Isha, do you want to tell them all thank you and wish them best for their season?
Thank you all for joining us today. We hope you had a great learning experience.
This is the team that was helping out. We are at a fire station here near where we all have our meeting place. Thank you all so much. All the best for season. But if you have any questions, we're happy to continue answering them. So if so those of you who want to leave, you can feel free to leave. But those of you who do have questions, please stay on. We are happy to answer questions for however long you want.
Thank you so much for setting up this camp. It was very helpful, and you took the time and went through everything. So really appreciate it. I do have one question, and so we are a rookie team and trying to figure these things out as we come across. So one thing I was going to ask was on the control hub, we have all these ports. So I'm able to tell we have the motor encoder on the left, we have the servos in the bottom, and you said the sensors going to the do all sensors go to the I2C, and also what are the other ports on the right side for?
Okay, so I'm actually going to go ahead and disconnect all this so I can bring the control hub closer.
Okay, sure.
Guys, I'm good with disconnecting everything, right? Yeah. Okay. Okay. So I think as we have covered, there are two power ports here. One is for the input power. The other one will be utilized when you want to connect an expansion hub. And I think
Okay.
so let me just... And again, there should be documents and other images showing this, but we just want to cover this in the camp. So you'd be using one of these for input power, and then the other one would go from here onto the expansion hub. Now, if just from the layout perspective, if it makes more sense to have the power input go to the expansion hub and then the other one connect to control hub, that's fine too. That also works. So you're not stuck with one of them having to be the input. Yeah, as long as they connect to each other. And then there's a data port that has to go from the control hub to the expansion hub. And guys, is that the RS-485 port that goes from the expansion hub to the control hub? We have that over there. I want to make sure we get that. Yeah, it is the RS-485 port. So you can see there are two RS-485 ports, one here and then or two over here and two over here. So that's where you want to connect the data connection between the control hub and the expansion hub.
Okay.
Next, so next, going back to just the control hub, as you can see here, like for port 0, there's a power port and then there's a data port. That's for the motors. We have 6 servo ports, so that's these 6 here. And the 5-volt power, we have never had to use that. So I will leave that to your needs if there is a need. Now the I2C sensors. Most of the advanced sensors are I2C sensors. So the distance sensor and the color sensor are both I2C sensors. Now you could have some other kinds of sensors that you want to use, which could be analog or digital. Now for analog, I know there are some potentiometers and other such sensors. Now we've never had to use any of those. Let me ask a quick question for the team members here. Guys, do you remember the touch sensor? Is that an I2C sensor as well? That's a digital sensor? Okay, so the touch sensor, which is essentially like a button, that is going to be just a digital sensor, not an I2C sensor.
Okay.
And just want to add this here. One way in which we have used a touch sensor is whenever you have like a slider or some arm mechanism and it comes down to its resting position, we have a touch sensor there so that when it rests, we know that it came back. That way, you are resetting the encoder positions to 0. This
Okay.
has been helpful because it's another way of, it's the equivalent of in FLL. Sometimes we would back up against the edge of the table just to reassure ourselves of our location. The same way, we could use a touch sensor. They call it a limit switch in the industry and in FRC and things like that. So basically, we're using the touch sensor or the button as a limit switch. You do get separate limit switches, which are not necessarily the ones Rev provides, but they in fact have a longer metal piece sticking out. So they will work better as a limit switch than a touch sensor might, but just throwing out those options there.
Okay.
So I would say you'll almost always use an I2C, and of course with the touch sensor, you'll use digital. Analog, I know Rev makes the potentiometer and at least one other, but we have never had to. I think it's a magnetometer or something like that, but we have not used either of those.
Okay. All right, sounds good. Thank you. Thank you so much.
Okay, does anyone else have any questions? If not, have a great season. Best of luck, everyone. So we will be emailing the slides, so location to the slides, and this recording, we'll edit it and then put it up on YouTube and share it with everyone who had registered. So please look for that maybe by the end of the week. And you have our team email, so feel free to message us at any time, even during the season. We'll be happy to assist. And we typically do that. We usually mentor about 10 to 12 FLL teams and about 4 FTC teams every year. And we assist any teams that reach out for any kind of help that they might need. So these students that have been on FTC teams, like I mentioned, Beta Bionics and Emerald Box, they made it to Washington State finals for power play. It was 2 seasons ago. In fact, they went against each other in finals. And one of them ended up winning the Washington State Championship. So we have good experienced FTC students here. So any kind of help, please don't hesitate to reach out.
Thank you. One quick thing. Would you be able to put the email address on the chat?
Yeah.
I can search and find, but
Yeah, we'll do that right away. The first thing I wrote would be at Gmail.
.com. Don't forget it.
Yeah.
I was somewhere on the next person. No, it's not. I'm not stupid. I'm not stupid. I'm not stupid. I can't even know. It's not even on. It's over there.
Okay, all right. Thank you, everyone. And we'll be accessible, like we mentioned. So have a great season. First weekend of September is when it will be announced. I would suggest if you have a place you can go to for the kickoff, because there are a few schools that will host a kickoff. It's so much fun, just the energy, because I know everyone's going to be excited and you will start off with that great energy and some great conversations at those kickoffs. Okay, all the best.
oh, thank you. Bye.
Bye.